Now we have all heard from our math teachers at some time or another that a to the 0 equals 1, and a can be any real number. For instance, I can say 2 to the 0 equals 1. I can say pi to the 0 equals 1. I can say negative 32 to the 0 equals 1. And the question is, why is that true? Now, this is a proof that is pretty straightforward for people to understand as long as you remember your rules of exponents. All right, it's nice to know why things are the way they are in mathematics. If we can at all show you how, it's important to know why. Okay, so let's start with a to the 0. And each part, I'm going to make an equivalent statement and think about it and tell me why you think it's right. So a to the 0 equals a to the m minus m. Now, of course, that's true because if you have m items and you take away m items, you have 0 items. So that's the same statement. A to the 0 is a to the 0. I can also write this as a to the m plus negative m. Now I write it that way. That's just the same thing as saying, 2 minus 3 is equal to 2 plus a negative 3. It's the exact same statement. Okay? So now I can rewrite that using a rule of exponents now. I can rewrite that as a to the m times a to the minus m. That's using the rule that says a to the m plus n is a to the m, a to the n. Now I want to write this with a positive power. And we know that a to the minus n equals 1 over a to the n. So I'm going to use that rule next. That's equal to a to the m times 1 over a to the m. Now what I have here are two numbers I'm going to multiply together. So I'm going to write this as a fraction as a to the m over 1. So it's a to the m over 1 times 1 over a to the m. Multiply numerators. Multiply denominators. And I end up with a to the m over a to the m, which is also the same thing as 1. So if you follow backwards, 1 is equal to this, 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 equal to a to the 0. Therefore, we can say a to the 0 equals 1.